Students, yesterday's lecture we discussed the unguided media. Now today we will continue with the guided media, the remaining types of guided media. In guided media, uh, we have covered their types. So the very first is the coaxial cable. So the transmission line that consists of a tube of electrically conducting materials. So these are some electrically conducting materials. Here I have put up the two images, the original image as well as the uh, some representation. And consists of electrically conducting materials surrounding a central conductor. So this is the central conductor, or this you can say that the central conductor held in place by sorry. So this is the central conductor. This will be the central conductor. In a conductor, you can say that this is the central conductor held in a place by insulator. So these are the insulators. Here you are not able to see the insulator, but actually there is being implemented very thin plastic cover. So if you have you seen this kind of wire at your home? Yes, anyone? Basically, your dish TVs are using these kind of wires to uh, make yourself make your TV operable. So it will receive the dish will receive the signal and send the signal through this wire to your TV. So this is the inner conductor and having insulator over it, and then we have this net-like wire. So this is the net-like wire. This golden wire is net-like wire, and again some thin insulator is being implemented, and the whole wire is covered with the plastic cover. So this black color is the plastic cover that is being implemented. So this is used to transmit the telegraph, telephones, television, and internet signals over the medium over it. From center to the receiver, and it is also called as the coaxial cable. So before we move on to the optical fiber, first of all we will see the bending of the light rays. So how the light has been bent. So basically when so we have two scenarios. First a refraction and next a reflection. So refraction is when the light rays are passed through this dense medium. Okay, so like this is the dense medium, more dense medium, this is the less dense medium. So when light passes from more dense to less dense, this is called refraction, and the critical angle is less than the angle I of the light with the base. So then again refraction is there when the light passes and move on to the surface of the more dense medium, and in which the angle of light is equal to the critical angle. Again at that point refraction is there because it has passed the more dense medium, and then reflection when the angle of light is greater than the critical angle, the angle with the base of this light. Okay, so this reflection will be happen. So refraction is the bending of light with sound, water, and other waves as it passes from one transparent substance into another. Okay, so this bending of refraction makes it possible for us to have lenses, magnifying glasses, prisms, and rainbows. Clear? Then we have the optical fiber. Again, I have slide two images of optical fiber over here. So first of all, see the optical fiber. The fiber in British India is a flexible, transparent fiber made by drawing glass or plastic to a diameter slightly thicker than that of human hair. Okay, so this wire is very thick and the light is kept in the core by phenomena of total internal reflection, which causes the fiber to act as a waveguide. So basically this is the sender, and it will send signals to this receiver. And let's see how the optical fiber made. This is the outer jacket, and in that the strength member, basically the actual part on which the signals will travel is just like this. This is the thinnest part of the wire in which we have the signals to be transmitted, and after that we have cladding that will be of more dense medium, and then the coating is there, strength member, and at last we have the outer jacket. So basically whenever the center signals, it will move like this, the total internal reflection over here in the core part, and the angle should be greater than the critical angle, so that it will not pass to this cladding. If that will be passed, like if something this like happen, we will lose the signals. Okay, and one more thing is that to use this optical fiber, you will put that wire into the straight form. Means like this, the optical fiber will be implemented, not like this, because total internal reflection phenomena is there, so we can lose the signals when there are more and more bands in the optical fiber. Clear? So then propagation modes are there. First is single mode. So multi-mode we have step index and graded index. So see, the source is sending the signals and the destination we have saved like this. So multiple mode with step index are used. So one is the state data will travel from source to destination, and then two at different critical angles. Similarly, we have second graded index in which source is there. First line is straight and other second is like this, and whereas the third only single mode will be used from source to the destination. So these are the fiber types. Type 50 to 155 core is micrometer is 50, cladding is 125 and used for multimode and graded index. Then 62.5 to 125 core is 62.5 and cladding is 125. So again used for multimode graded index. Third is 100 to 125 used for multimode and graded index, and 7 to 125 7.0 and 125 the cladding, and single mode will be used in it. So this is the construction of this fiber that we have already discussed this part. This is the glass part or plastic cover in which the signals will be transferred and then cladding. After that, we have the strength material, and then the plastic wafer is used sometimes, and this is the outer jacket. So these are some connectors of this fiber optic cable. So SC connector is there and ST. So these are the fiber optic cable connectors. Let me just show you a video in which you will get more clarification about these fiber optics. Just wait, I will start the video.